Today we're going to be introducing rational functions and function notation. And so this is a concept that's going to come up in calculus, but we're going to talk about where it comes from here in Algebra 2. So we're going to start first by just looking at how we would find the slope between these 2 points. So if we have these 2 points that are given to us, we have the coordinates 1, 3, and then these coordinates here are 4, 8. And we want to find the slope between those 2 things. So we could count rise over run, but we can also use our slope formula from the past. So our slope formula is y2 minus y1 over x2 minus x1. And so if we're finding the slope between these, we would have 8 minus 3 over 4 minus 1. And then when we simplify that, we would get 5 over 3. And that can't simplify at all, but that would be our slope. Okay? So let's look and see what happens if we have just a general case. So if we say we didn't have these grid lines here, this point here would be the coordinates x and then f of x. Because x is the x coordinate, and then the y coordinate is what you get out after you plug in that x value. Okay, so we have a coordinates of x and f of x. So let's look at another point like that here. So if we have this point right here, and again we're kind of ignoring the fact that there are grid lines there, we have x and then comma f of x. And we're going to move that point somewhere here. Okay, and this distance here is h. So that means that the coordinates of this point would now be x plus h, because we want this x distance, h more spaces this way, and then our y coordinate would be what we get if we plug in x plus h to the function. Okay, and so if we use that same idea of finding slope between these 2 things, so our slope would be the y coordinate of the one point minus the y coordinate of the other point. And then here we're going to take the x coordinate and subtract the x coordinate from the other one. And if we look at this, this simplifies to be f of x plus h minus f of x all over, those x's cancel out, and we just get h. So this is the formula that we're going to be using for this. Okay, this formula tells us the average rate of change or slope of any secant line for any 2 points on a graph. And in pre-calculus and calculus, you will work on finding instantaneous rate of change. That's going to tell you how fast or what the velocity of a particle at a given time is for this. Okay, so that's kind of what we're working towards, but these are rational functions. That's why we're going to be practicing them here. Okay, so we're going to look at a couple of these today. I'm going to put our formula here again. And again, this is just the slope formula. Oh, that looks not like a minus. Okay, so we have f of x plus h minus f of x all over h. That's our formula. And our function is just going to change for this. We don't have to graph anything for this. The first one we're going to do is f of x equals x squared plus 3x minus 1. And we're plugging in to this formula. F of x plus h means we're taking this value and plugging it in for x. If it said f of 2, then we would plug 2 in for all of those x's. So since we have f of x plus h, everywhere we see an x in this, we're going to plug in an x plus h. We're going to take that and subtract the original f of x function. So we want to make sure that we put that in parentheses, or if you don't want to, you have to distribute that negative through to everything. And then this is all over h. Now that we have this, we're going to actually simplify. So x plus h squared means that we have to multiply it twice. So we're going to have x squared plus 2xh plus h squared. We're going to distribute the 3 in, so plus 3x plus 3h. We have our minus 1, and then we're going to distribute that negative in. So minus x squared minus 3x and plus 1. and this is still all over h. Now what we're doing is simplifying in the numerator what we got going on and crossing off like terms or things like that. So the x squareds can go away, the minus 1s can go away, and the 3x's can go away. And so what we have left there is 2xh plus h squared, so 2x squared, 2xh plus h squared plus 3h all over h. And so with this, now we notice that every single term that we have left has an h in it, and that's meant to be there on purpose, because now we can take an HGCF out of this. And that HGCF is going to cancel with this h from the bottom. So our answer for this is 2x plus h plus 3. Now, this doesn't mean very much to you right now. It will mean more when you get to pre-calculus and calculus, but that's what our answer is. That technically is the slope for the secant line between 2 points on this function. Okay? So we're going to look at another one here together. So if we have f of x equals 1 over 2x, now we're getting a fraction within a fraction here. We're going to do the same thing again. So we have f of x plus h. So that means everywhere we see an x, we're going to put an x plus h in its place, minus the original function, so 1 over 2x, all over h. And that over h is the last thing that we're going to deal with as we're solving these questions. So we're going to get a common denominator. Now this is just a complex rational. So in the numerator here, our common denominator, they have a 2 in common, and then we need to grab an x and grab an x plus h. The first fraction's missing the x. The second fraction is just missing the x plus h. So when we distribute that in, we're going to get x minus h. And this is still all over h. Okay, combining like terms in the numerator there, we get negative h over the common denominator. And since this is still divided by h, that's the same thing as multiplying by 1 over h. Here our h's are going to cancel, and we'll go this way. We're going to be left with negative 1 over our common denominator of 2x, x plus h. And so that is our answer. Okay? Again, f of x plus h minus f of x all over h is what we're solving. Let's look at one more that has multiple variables in it as a fraction. So we have 2x, f of x equals 2x over x minus 1. Alright, so we're finding f of x plus h first. So that means that everywhere we see an x, we're going to plug in x plus h. We're subtracting the original function, and that's all over h. Now that we have this, we're going to build a common denominator between these. Okay, so this is a trinomial, this is a binomial. You cannot take parts of those to be your common denominator. So we're going to go ahead and take everything from those. So we're going to have x plus h minus 1 and x minus 1 is our common denominator. Now, that means that this first fraction is missing the x minus 1. When we multiply these things, I'm going to actually go up here with my work. We need to distribute, we've got 3 things to multiply. I'm going to multiply the parentheses together first. So that would give us x squared minus x plus xh minus h. And then we're going to distribute the 2 into that. That 2 is still on the outside of this. So that would give us 2x squared minus 2x plus 2xh minus 2h. the second fraction here is missing the x plus h plus 1, or sorry, minus 1. And so when we distribute that in, we get negative 2x squared minus 2xh plus 2x. So running out a little bit of space there. That's still all over h. Now we're going to see what things cross off here. So the 2x squareds are the same. Negative 2x and positive 2x are the same. 2xh and negative 2xh are the same. And so what we're left here with is negative 2h over our common denominator. Oops. Okay. And that's being divided by h, which means we're going to multiply by 1 over h. Our h's will cross off, and that leaves us with our final answer of negative 2 over x plus h minus 1 times the quantity x minus 1. So we just need to make sure that we're remembering the formula f of x plus h minus f of x all over h.